Evaluate each expression. We have log base 9 of 3 plus log base 9 of 27. Now, these individual logarithms we could certainly figure out individually. However, we are adding two logarithms with the same base. So we have a logarithm law that tells us we can combine those by multiplying what's inside. So we've got 3 times 27 inside. So this is log base 9 of 81. And this is much easier to see. This is just saying what exponent do I put on 9 to get 81? And that is, of course, 2, because 9 squared is 81. So this addition here is equal to 2. This next one actually is not, we would be able to do this individually, right? Log base 3 of 45, there's no way to just know what exponent we'd put on 3 to get 45. Same thing for getting 5. However, we are subtracting two logarithms with the same base. And so we have a logarithm law that says we can combine those by dividing those inputs. So 45 divided by 5. And this is, well, 45 divided by 5 is 9. Well, log base 3 of 9 is what exponent do we put on 3 in order to get 9? And that is 2. For part C, we have this number out in front. And we have an exponent, or a logarithm law that tells us that a number out in front can actually come up to be the exponent on this number inside. And so we have log base 9 of 27 to the negative 1/3. And so we need to kind of figure out what this is. Okay, so in the parentheses here, we have, first of all, a negative exponent, so that's 1 over 27 to the 1/3. And then an exponent of 1/3 is a cube root. So this is 1 over the cube root of 27, which is 3. And so now we need to figure out what exponent do I put on 9 in order to get 3, or sorry, in order to get 1/3. And this may not be as super obvious. I'm going to go ahead and write it in exponential form. So I'm going to say I've got this thing equals some number x, and we need to find that x. So writing this in exponential form, we have 9 to the x equals 1/3. And I'm looking for this exponent, and the easiest way to do that is going to be to write these two things using the same base. Okay, so 9 I can write as with a base of 3 as 9 squared. So this is 9 squared to the x, and then 1/3 I can write as 3 to the negative 1. And then on the left side here, I've got, if I can use my exponent rule, I can multiply those exponents. So 3 to the 2x equals 3 to the negative 1. And now I've got these two exponents that need to equal each other. So 2x must equal negative 1, therefore x must equal negative 1/2.